Let's talk about the LeetCode 2471, minimal number of operations to sort a binary tree by level. So you give us a binary tree, and in one operation, you can choose any two nodes by the same level and swap their values. And return the minimal number of operations. You need to make the values at each level sorted in strictly increasing order. And you see that those nodes are unique. So ask what's the minimal swap time. So because we want to sort for each layer, right? So that is every layer, we just need to consider for each layer how many times to swap to um to get it sorted. And for every layer, we add the sorted number to the total result and get the result. So to do the things by the layer, um, intuitively we're thinking about is using BFS, right? So this will be kind of classical BFS solutions. And for every layer, we create an array and trying to see how many for this array, right? What we do BFS is just by um and we have the original array is the original order for example that is the array this has size 2 in the array index 0 is 4 and 1 is 3, right? And for this layer and the index 0 is 7, 1 is 6, and 2 is 8, and 3 is 5. And it asks how can we find the minimal swap time, right? So for an array, how to find how many times it can be swapped, right? For example, we have um, 2, 3, 1, 4, right? So for this kind of scenario, how many times you need to swap is that actually you see this is just a circle, right? So this circle size has size 3. So actually this one is just to just equals we need to swap twice. That's enough, right? Because circle that means um we should have one goes to this direction, right? And then 2 goes to this direction, 3 goes to this direction. So for these arrays, so no matter how many circles, right, we have, then for this circle, it has size, for example, A, this has size B. Then the total result will be A plus 1 plus B plus A minus 1 plus B minus 1, right? And for example, there are say some other circles, there is plus C minus 1, just sum of them up, right? And when we write, for example, count number, how to do the circles, we don't need to um do DFS to find the circle. Instead, we can, for example, find what is for example, we have a number array here, right? And we can create a sorted array called sorted, which is um, a copy, a deep copy of this array, and also sort this one, right? So when we go through this array, we find this number should be um, when we find this number is not uh, sorted this number, right? So what we need is that we put this sorted number into a map, right? So for this sorted number, for every number, we have the number into the as key and the index as a value, right? So we find where is this number exists in this sorted number, for example here, right? Then if we try to swap these two, right? And so 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 the thing is that if we are able to using swap to get this value, right, array I, we find it here, right? J by swap, it get this array I to be the sorting number. Then we just um, stop. Right? So every time we swap, we add the result. And this, if this I just swap one time, it still doesn't equal to this 30i because this may be swapped by some other values, right? Then what we need, we do is we swap here, right? Find another number. This array I become new number. So we find a key here, right? Use the map to get a key. Then we keep swapping the array I and k, right? So this just by this kind of I, J, K, if these are circle, right, it will ultimately swap this array I to a correct number. So every time we go through this is a circle, right? So then we just do a subset of this kind of circle. So the total even we do while loop for for this array I and why this doesn't equal to sorted I, then we keep swapping. The whole time complexity will still be on because we do this for circle, and for the circle, the maximal number of the time is a circle size minus one, right? And the circle size is a constant in this kind of set. This circle doesn't have interactions with the others. So we can write code for this. So we know we have result, right, for 0. Then we'll have Q. We have 3 nodes Q equals new array there. So we have Q offer root. Then what we do is to while this kind of Q is not empty, then we're going to have a int size, right? Equals Q dot size. And what we need is that we need to have this kind of array, right? And equals new int size. Then what we do is for int I equals to 0, I small in size I plus plus. Then tree node current equals Q dot 4. And we'll have array I equals current dot value, right? And I will say if this current dot left does not equal to null, then we need to Q dot offer current dot left. And let's say if current dot right does not equal to null, then we're going to have Q dot offer current dot right. Right. So after we do create this array, right? We need to have, for example, result is add equal to count the many of times of swap, right? And in the end, return result. So we need to write a have function count. So this count is just count the times to get to using swap to get this array into sorted order. So I have int n equals array dot length. For example, result we can also set as 0, right? So we're going to have int sorted equals arrays copy of arrays. Let's have a copy of array with length n. Then we arrays sorted sort, right? Array sort. So the thing is that we can use a map to um put those kind of values, and it the index where it should be, right? New hash. So what we do is that for int I equals to 0, I smaller than int I plus plus map put sorted I in I. So that means this value should uh, be put in this index I. Because these kind of values are unique, right? We can put use map here. Otherwise, um, it will be a bit complicated. So what we do is that for int I equals to 0, I smaller than n, and I plus plus, right? So we'll say if this kind of while this kind of array I does not equal to sorted right. So that means at the index I will not will not put our correct data here, right? So they are not putting a correct I is not being correct ordered yet. So what we do is that we can get the position of which array I should be, right? It should be map get array I. Then we just swap, right? Into temp equals I array I equals array j array j equals temp, and we have result. We swap once, right? And then in the end, return result. And let's write a Python code for this as well. So we're going to def count how many times to swap, right? And for our main function, we'll return, for example, let's return something, right? And for our main function, we'll say uh result equals 0, right? And Q is that we put root in it, right? So what we do is that while this Q is not empty, then we're going to have size equals length Q, and we'll have array equals this, and for in range size, we're going to have current equals Q dot top left. And then we're going to have array but append current dot value, right? So we'll say if current dot left is not null, we're going to have q dot append current dot left. And we'll say if current dot right is not null, again the q append current dot right. Right. So for every layer, we need to have result should add equal to count array, and in the end return result. And we need to implement this counts, right? So we can have n result equals length of array, and this result initial set as 0, right? And we can have sorted array equals sorted array, right? And we have index map equals so that our value as key, right? Uh, index for um, index value in enumerate sorted array. Right? Then what we do is that for I in range n, we're going to have wow, this kind of array I doesn't equal to sorted array I. Then we're going to have using the J equals I map it uh, I map array array I, right, array I. Then we just keeping swap array I array J equals array J array I, and we'll have results to the plus equal to 1. In the end, return results. So doing like this, we'll say we have use a queue, right? So for each layer, for example, the maximal nodes is k, right? So it will space be linear. The maximal layer that will be OK, right? Proportional to ON, but it's depend on the what is the size, what shape. For example, if it is like a the worst case, the worst case is that have one this it is binary tree, right? Binary tree should be um half, right? So um in the space, the time complexity, right? Because we have a thought here. So for every layer, it is a k log k, right? So the total is n log n, right?